Hey guys, it's Rob again from BreVITy, and in this video we're going to solve the binary tree zigzag level order traversal problem on Leetcode. So let's get started. So coming to Leetcode, we can see that the problem statement is as follows. Given a binary tree, return the zigzag level order traversal of its nodes values. And by level order traversal, they mean from left to right, top to bottom, and it's going to be alternating in between. So what they mean is every other level of the tree will be returned in the reverse order of that particular level. So for example, in this particular tree which they have given, the output is going to be 3, and then the second level is going to be from right to left. So we have to output 29. And then the third level is going to be from left to right. So it's going to be 15, 7, and so on and so forth. So every other level is going to keep alternating. So the way we're going to solve this problem is by using the same algorithm we used for the previous problems. And that is going to be the level order traversal, which we implement using the breadth first search. So by now you should be used to this technique. If you haven't watched the previous videos yet, do watch those videos before coming over here. So we're going to implement it in the same way as the previous video. So first I'm going to declare the array list of type list integer, which is going to be the output of this particular method, as we can see over here. So let me just increase the code size, and here we go. So the first thing we're going to do is declare array list of type list integer result is equal to new array list of type list integer. Next we have to declare the queue, and we're going to declare the queue using the deck data structure in Java. So we're going to say deck of type tree node queue is equal to new linked list. Now for those of you who are wondering why I have declared the deck to be of type tree node, it is because inside this particular queue we're going to keep inserting data of type tree node. So tree node is declared over here by Leetcode, and as any other binary tree we have three things: the value, the left node, and the right node. So for those of you who don't know what a binary tree is, a binary tree is a data structure. A data structure is a structure which stores data, and a binary tree will have three values: the value, the left node, and the right node. So we can see over here that 3 has this particular node on top, the root node, has a value of 3, and the left node is 9 and the right node is 20. So now moving on, we're gonna do the breadth first search, right? So we have to declare a while loop while the queue is not empty. So first we are gonna declare it starting from the root node. So we first need to add root node to the queue. So I'm gonna say queue.add root. Now after this we'll begin the while loop, and the while loop is gonna keep running until the queue is not empty. So while queue is not empty, I'm going to take the current size of the queue and declare it as size. So int size equals queue.size. Now the reason we do this is we need to know when we have bypassed a particular level. So once we have found all the nodes of a particular level, we'll terminate the for loop which I'll be declaring, and then we'll go to the next iteration of the while loop. So once we finish all nodes of a particular level, we need to move on to the next iteration of the while loop, which will cover the next level. Okay. So before this, I'm going to declare one more variable of type int, which is going to be called level. And I'm going to declare it as 0, and I'll explain why I'm doing this in just a bit. So the next thing I'm going to do is open the for loop as I mentioned, and for int I equals 0, I less than size, I plus plus, the typical thing. And inside first I'm going to declare a list of type integer. I'm going to call this list is equal to new array list of type integer. So inside the for loop, I'm first going to remove an element from the front of the queue. So the way I do that is tree node temp is equal to queue.poll. So what the poll method does is it removes whatever element is in the front of the queue and returns it to us. So right now we are storing that particular node in temp. Next, I'm going to add the value of temp to the list. So list.add temp. And next we have to check the left hand side and right hand side of this particular temporary node and check if it is equal to null or not. If it is not null, we are going to add it to the queue so that we'll check it in the next level, which is going to be the next iteration of the while loop. So what I'm going to say is if temp.left is not equal to null, queue.add temp.left. Similarly, if temp.right is not equal to null, I'm going to say queue.add temp.right. So here we'll be making a small change to what we are normally used to. We can notice over here that assuming the first level to be level 0, every even level is going to read the values from left to right, which is the normal way we look at things in a level order traversal. Whereas level 1, level 3 and so on, all the odd levels are going to be read from right to left. So that is why I declared a variable over here saying int level is 0. So initially we are at the 0th level. So if this particular variable level is divisible by 2, then we can assume that we are in an even level and then we have to read it from left to right. But if that particular level is not divisible by 2, then it's an odd level. So in that case, we need to read it from right to left. So all we have to do is reverse this particular list where I'm adding the values. So inside the while loop, I've been adding these values to a particular list. So over here, I'm saying list.add temp, right? It has to be temp.val, by the way. Yeah, so list.add temp.val. So in every odd iteration, all I'm going to do is reverse this list and then add it to our result list. Whereas in even iterations, I'm simply going to directly add it to our result list without reversing it. So the way we do that is if level modulus 2 is equal to 0, then I'm going to say result.add list. So directly we'll be adding list. Whereas if it enters the else condition, then it's going to be we're going to say collections dot reverse list. So this is how we reverse an array list in Java. And then we're going to add this particular array list to our result. So I'm again going to be result.add list. And outside of this, since we have finished one particular level, I'm going to say level plus plus. And then we'll go to the next iteration of the while loop. So now let us run this code and check for any compilation errors. Okay. Yeah, I forgot to return result over here, so that's a pretty obvious error, so I don't need to say step 3 debugging. Okay, so now we can see that the test case has passed. So now let us think of any edge cases. So step 2, checking for any edge conditions. So over here, one of the obvious edge conditions whenever it comes to trees is what if the root node is null. So in that case, we have to directly return that empty result. So what I'm going to say is over here, if root equals null, then what we're going to do is return result directly. We don't need to check anything else. And now let me submit the code and check if all the test cases pass. And we can see that all the test cases pass with a very good time and space complexity. So now let us move on to step 4, which is optimization. Why do we need to optimize the code over here? Already we are getting a runtime of 0 ms, which is faster than 100% of Java Online solutions. And we can see that there aren't any obvious things which we can change in order to reduce the size of our code. So in this case, we can skip step 4 and directly go to step 5, which is time and space complexities. Now for this particular code, the time complexity is going to be O of n. That is because in the worst case, we're going to iterate through each of the nodes only once. So that is why we're going to have a linear time complexity, which is going to be of O of n. Now the space complexity of this solution is going to be O of n as well. That is because we're declaring a deck over here, which is of type linked list, and that is going to occupy additional storage in memory. So that is why the space complexity is going to be O of n as well. And on that note, we come to the end of yet another Leetcode video. Really hope you guys enjoyed. As always, if you haven't subscribed to the channel yet, do remember to hit that subscribe button to be notified of future videos. This was Rob. You're watching BreVITy. Thank you and goodbye.